It is a mental process, consists of using various methods in an orderly manner for finding solutions to problems. The problem-solving techniques are used in many disciplines and science is also one among them. Apart from knowing of facts, the subject is expected to develop science process skills where children observe, measure, classify, process information, interpret, think on solving problems, formulate conclusions. A problem-solving approach, as the name suggests, is an approach where children learn by working on problems. The students learn new knowledge by getting exposure to face the problems to be solved. This approach prepares them to observe, understand facts, analyze and interpret, find solutions and perform applications. Hence, such an approach leads to a comprehensive understanding of concepts. Problem solving is and should be an essential part of science curriculum. It assumes that students initiate some of the responsibility for their own learning by taking personal action to solve scientific problems, discuss alternatives, and fix to solve the problem. It provides students with opportunities to use their newly acquired knowledge in meaningful, real-life activities and assist them in working at higher levels of thinking. Problem solving is a process, an ongoing activity in which students discover what they don't know. It involves overcoming obstacles by generating hypotheses, testing those predictions, and arriving at satisfactory solutions. The effectiveness of problem-solving methods in science learning and process skills is well discussed in several researches. Elwan et al. Studied that both problem-solving and traditional teaching methods have positive effect on students' achievement. But the study results reveal that problem-solving method is more effective than traditional teaching methods and improved the scientific process skills among students. According to the research done by Ebel and Pisney during 1992, the problem-solving approach in classes resulted in increased use of brainstorming, an increase in time allotted to defining, sharing, and presenting the problem, as well as more student-selected research questions and student-designed investigations. Children with visual impairment, like any other sighted child, must learn to think for themselves, to problem solve, and to think logically. But, unfortunately, they lack opportunities for incidental learning that occur for their sighted peers almost constantly. Without such opportunities, associating words with elements of the environment is difficult. Thus, it is important that such associations be supplemented with input from other senses and through alternative activities. The limited nature of visual associations for students with visual impairments has classroom implications. Problem solving is the necessary skill that the visually impaired student must learn. Alternative ways of handling a situation are to be taught rather than automatically giving them the solution. Students should be encouraged to think of the alternatives and reinforcements as well as timely feedback should be provided. seeking information, generating new knowledge, and making decisions. By keeping in mind these steps, students can easily solve problems in science classroom. The first step is understanding the problem. Understanding the nature and magnitude of a problem and its related goals would help the students to gain confidence to work further. The second step is finding barriers, if any. Students need to be aware of any barriers or constraints that may be preventing them from achieving their goal. The third step is identifying various alternative solutions. After the nature and parameters of a problem are understood, students will need to select one or more appropriate strategies to help resolve the problem. The fourth step is trying out a solution. Students need to understand that there are many strategies available and no single strategy will work for all problems. Last step is evaluating the results. It is imperative that students have multiple opportunities to assess their own problem solving skills and the solution they generate from using those skills. Creating visual images. Many problem solvers find it useful to create mind pictures of a problem and its potential solutions prior to working on the problem. Mental imaging allows the problem solvers to map out many dimensions of a problem and see it clearly. The next is Guesstimate. Give students opportunities to engage in some trial and error approaches to problem solving. It should be understood, however, that this is not a singular approach to problem solving, but rather an attempt to gather some preliminary data. Creating a table. A table is an orderly arrangement of data. When students have opportunities to design and create tables of information, they begin to understand that they can group and organize most data relative to a problem. Use of manipulatives. By moving objects around on a table or desk, students can develop patterns and organize elements of a problem into recognizable and visually satisfying components. Working backward. It is frequently helpful for the students to take the data presented at the end of a problem and use a series of computations to arrive at the data presented at the beginning of the problem. Creating a systematic list. Recording information in list form is a process used quite frequently to map out a plan of attack for defining and solving problems. Encourage the students to record their ideas in lists to determine regularities, patterns, or similarities between problem elements. Learning by doing means learning from experiences resulting directly from one's own actions. It is in contrast with learning from others' performances, listening or reading to others' instructions or descriptions. Though watching, reading and listening refer to actions, they are not the kinds of doing referred to as learning by doing, since they yield direct experience with demonstrations or descriptions of actions rather than with actions the learner actually performs. Now, we shall see the more important 4 steps of learning by doing as given by chemists. The first step is planning, prospective or prior to action and forward looking. Recognize that all social actions is to some degree unpredictable and therefore somewhat risky. Planning is flexible enough to adapt to unforeseen effects and previously unrecognized constraints. Strategic, taking into account the risk involved in social change and recognizing real constraints in the situation. Chosen because it allows the practitioner to act more effectively over a great range of circumstances more wisely and more prudently. Action. Actions are deliberate and controlled, careful and thoughtful variation of practice. Practice as idea in action. Actions are guided but not controlled by plan and prior practice. They are risky in real time, dealing with real constraints. Sometimes they are fluid and dynamic, instant decisions and practical judgment. Struggle towards improvement. The next one is observation. Documenting the effects of action is observation. Prospective is it provides the basis for reflection now, but more so in the immediate future. Careful observation is necessary because action will always be limited by constraints of reality, and all of these constraints will never be clear in advance. Observation must be planned so that there will be a documentary basis for subsequent reflection, but it must not be too narrow. It must be responsive, flexible, and open-minded. Observe the action process, observe the effects of action, intended and unintended, observe the circumstances of and constraints on action, observe the way circumstances and constraints limit or channel the planned action and its effects on other issues which arise. And these observations are guided by intent to provide a sound basis for critical self-reflection. The last step is reflection. Retrospective recalls action as it has been recorded in observation. It seeks to make sense of processes, problems, issues, and constraints made manifest in strategic action. It takes into account of the variety of perspectives possible in the situation. It is aided by discussion among participants. Through discourse, a reconstruction of the meaning of the social situation leading to a revised plan. Evaluative aspect of this is practitioner is to judge whether effects or issues were desirable and suggest ways of proceeding. The descriptive aspect of this is new understanding, a more vivid picture of the situation, the action, and what might now be possible. Students, when they physically experience scientific concepts, understand them more deeply and secure good scores in examinations. Most of the students with disabilities benefit from learning science through an activities-oriented approach that reduces the reliance on textbooks, lectures, knowledge of vocabulary, and pencil and paper tests. This kind of approach seeks to promote learning by providing students with experiences that allow them to discover and experiment with science. Through discovery and inquiry, teachers involve students in creating and expanding their knowledge and understanding about the content area being studied. When employing an activities-oriented approach, teachers offer students a variety of active educational experiences structured according to a learning cycle. This cycle consists of an instructional sequence that includes engagement, exploration, development, and extension. The learning cycle begins with the engagement phase, whereby teachers use real-life activities, problems, and questions to motivate students to learn about the topic and to assess their prior knowledge. Students explore the content and phenomena by manipulating the materials and start to address the presented questions. For example, as part of a unit on simple machines, teachers can ask students to identify simple machines that they use and ask students to take apart broken household appliances. During the exploration phase, students formulate new ideas and questions to be developed in the subsequent phases. For example, teachers can have students explore how the household appliances work, identify their components and formulate hypotheses about how to fix them. In the development phase, students add to their understanding by gathering more information and making conclusions about the concepts, phenomena and questions previously generated. For example, students can use the internet to learn more about the appliances and to draw conclusions about how they work. In the final stage, extension, students extend their learning by applying it to new and different situations as well as to their own experiences. For example, students can hypothesize about how other machines and household appliances that they use work. Educators help students move through the learning cycle by asking them to think about questions, helping them find solutions, providing additional activities that further students' learning and aiding them in summarizing and evaluating their learning. Research shows that the interest of students with visual impairment in science tends to wane as they move through upper elementary into middle school and high school. The reason may be due to accessibility issues. However, provision of opportunities to participate in learning by doing would increase both the interest and performance of students with visual impairment. The benefits of learning by doing approach are numerous. It has been shown to improve both performance in the test and self-confidence of the students. Since learning by doing is interesting and motivating, discipline problems in the classroom and lab setting are decreased. Lack of or limited visual cues such as a schedule written on the chalkboard or seeing the clock can challenge these students from following classroom procedures or anticipating upcoming events. Opportunities should be given to the students to become acquainted with their classmates, as students with visual impairment may have difficulties to associate names and faces through incidental classroom experiences. It becomes the responsibility of the teachers to design appropriate experiences to help build relationships among all students in a class. Students have to be informed about the physical orientation of the classroom routines as well as other events that take place during the day. This must happen as soon as possible once the student is assigned to the classroom. Interaction with a model will not provide the same experience as interaction with a real object, especially when the visually impaired students have not had direct contact and interaction with the real object. For example, playing with a plastic plant has no meaning to the student who has not touched, smelled and explored with the real plant. Students with visual impairment have to be engaged directly with all aspects of the science learning process. Involvement in these repeated activities will enhance independence and minimize their reliance on others. It is essential to assure that the students take part in all the aspects right from the beginning till the end of the process when the process includes various steps. If the student only completes one or a few of the steps, they may be unaware of the remaining other steps that someone else completed. The students with visual impairment have to be allowed to move through the activity independently so they do not become dependent on others moving them through the motions. The teachers have to evolve strategies to help the students with visual impairment who cannot participate independently. They should be assisted throughout the activity by allowing them to complete the steps that they can do independently. Later, the assistance could be gradually faded until they can become independent. Students, particularly those who are totally blind, will need to be gently moved through the activity to make them understand what is expected. This is the best when the facilitator is behind the student so that the facilitator's body is oriented the same way as the student's body. Such repeated opportunities and natural experiences would assist the students to make associations. Responsibility and independence in doing the science activities help to unveil the potential of the visually impaired students. Students often perform in laboratories, solving problems and conducting experiments through learning by doing approach. This kind of learning experience could be maximized by showcasing and demonstrating essential aspects of problems and experiments. This could be done by allowing students with visual impairment team up with the sighted peers to work on a task, check their progress, and to maintain lab records. Today, we have seen the two approaches, problem-solving approach and learning by doing approach, to teach practical components to visually impaired students. Thank you.